Hi Sodbusters! If you've spent any time around this channel, you know that I keep bees in Layens horizontal hives. An obstacle for a lot of people wanting to get into beekeeping with Layens hives is that the Layens equipment is not readily available. Langstroth equipment is ubiquitous in the US, and if you go to any beekeeping store, any online store, you're going to find Langstroth equipment. But Layens equipment just hasn't hit the mass market like that. So if you want to get Layens hives or frames for those hives or any other equipment, then you pretty much have to either mail order it or build it yourself. In this video, I'm going to show you the process that I follow for building Layens frames. This is based largely on the plans and directions from Dr. Leo's website, horizontalhive.com. But there's a few steps, a few jigs that I made that are unique to the way I make the frames. If you don't have much carpentry or woodworking experience, it can seem like a daunting task to take on building your own equipment. But a frame for a beehive is a pretty simple project, and it's a good place to start to develop your skills. So I hope that watching this video and seeing the steps that I take when I build beehive frames will help to encourage you to take on this project yourself.
In this video, I'll be using power tools to build frames for the Layens beehives. I am not a professional carpenter or woodworker, and some of my techniques may not meet your shop teacher's approval. Please be safe when you use tools. A frame for a Layens beehive is taller and narrower than a typical Langstroth frame, at almost 16 inches tall and almost 13 inches wide across the sidebars. Unlike a Langstroth frame, the Layens top bar is solid, leaving no gaps between the frame tops once they are in the hive. Because a Layens hive is a horizontal hive, it's not necessary for the bees to move up through the frames. The top bars of the frames are made from a piece of 1x lumber, which has a nominal thickness of 3/4 inch. In this case I used a 1x10, but other widths could be used. I first cut the board to a length of 14 5/16 inches. Then I set up my table saw to cut out the rabbets on the ends. The blade is set to a depth of 1 1/16 inches, with 3/8 inches from the saw fence to the outside of the blade. Then I run the board through the saw to make cuts into the ends of the board. Make sure that you have the same side of the board against the fence for each of these cuts. By the way, you may notice some smoke as I make these cuts. My saw blade was dull, but I changed it after these. This work is much easier and safer if you use sharp blades. After you complete the end cuts, change the saw blade to a depth of 3/8 inches with 1 1/16 inches from the fence to the outside of the blade. I emphasize from past experience to measure to the outside of the blade. If you simply use the guide on your saw to set the distance, then you will remove more material, about 1/8 inches, depending on the curve of your blade. When you make these cuts, be aware that without some support behind the piece, like a sled, the cut piece will be kicked back by the saw blade. I am working outside with nothing right behind me that would be damaged, so I just stay off to the side and let the pieces kick back. But you should be aware that this will happen. With these cuts made, again making sure that the same side that was previously against the fence is now down for both cuts, you will have made the rabbets on which the frames will rest in the hive. Now set your saw fence to 1 1/2 inches and raise the blade to cut completely through the board. Then you can rip the board into individual bars. Please use a push stick and be very careful when working closely to the blade. You'll notice that I let the first few bars fall off the far side of the table, but unless you have a catch box, I don't recommend dropping your work pieces onto concrete. Once you've finished these cuts, you'll have a number of top bars ready to drill holes for wire and assemble. You will likely also end up with one board narrower than the rest. You might find these pieces useful as spacers in swarm traps, nuke boxes, or hives as needed. Bottom bars are also made from 3/4 inch thickness 1x lumber. The board is first cut to a length of 12 3/16 inches and then ripped in 5/8 inch thicknesses. Because this is a very narrow cut, please use caution and a push stick when feeding the board for the rip cuts. Except for drilling the holes for wiring, that's all that's needed to prepare the bottom bars for assembly. The end bars are made from 2x lumber, or boards with 1 1/2 inch nominal thickness. You can use any width, but as with the other pieces, you'll get more out of a wider board. Because the end bars are only 3/8 inches thick, They can be subject to weakness due to knots or splits. So the clearer the lumber you use, the more useful end bars can be made. The board is first cut to a length of 15 9/16 inches. Then that piece is ripped into 3/8 inch widths. As with the other pieces, be very careful and use a push stick for these narrow cuts. After all of the end bars are cut to thickness, then the tapers need to be cut. This can be done on a router table, but I use my table saw with a stacked dado blade. I built a jig for this with a guide piece that fits into the miter slot on the table saw and a slot through which the dado blade is raised. The top of the jig has a slot for the end bars and a stop block. The bottom of the slot is raised 1/4 inch after the blade to support the piece once material has been removed. The top of the bars should be 3 3/4 inches before the taper, so I want 11 13/16 inches from where the piece first encounters the blade to the stop block. The jig is clamped to the saw table to provide this dimension, and pieces are fed from the front of the jig. It's important to feed the pieces straight, without pressing down on the back or pressing down on the front of the piece until it's cleared the blade and is supported by the raised portion of the slot. When the pieces are fed straight, this provides a nice straight bar below the taper. If it's lifted or pressed down onto the blade, then the cut becomes wavy. As long as the waviness isn't too extreme though, I think it bothers me more than the bees.
If you're enjoying this video, would you do me a favor and give it a like while you're here? And I would sure appreciate if you would click subscribe and the bell icon so you don't miss the next video. Thanks a lot, and now back to the build.
If you will be wiring the frames, then the top and bottom bars need to be drilled. I made a jig for my drill press to do this, which simply has a slot for the bar and 2 pilot holes at the middle, one for top bars and one for bottom bars. The template has marks 1 inch and 4 3/8 inches on each side of the pilot holes. I used the smallest bit that I can put into my drill press. The plans call for a 3/32 inch bit, but that's just a little too small for my drill press chuck. For the top bars, the jig is clamped to the press with the middle pilot hole aligned with the bit. The piece is moved through the slot, bottom side up, aligning the bottom end of the rabbet with the marks on the jig. The piece can be slid through using all 4 marks, or drill 2 holes and turn the piece around. It doesn't really matter as long as the marks are the same distances from the center hole on each side. Please forgive the waviness of the video. This was an effect of the drill press vibration on the camera. The bottom bars are done in the same way, except that the pilot hole in the jig, which should be aligned with the bit, will be offset in the slot, 3/8 inches from one side so that it will fall in the middle of the 3/4 inch width of the bottom bar. The same marks are used, except now they're aligned with the end of the bar. To assemble the frames, I built a jig based on plans from horizontalhive.com. I'll put a link to those plans in the description. The jig helps to keep pieces together and aligned during assembly. I apply glue to each of the joints and put the parts together in the jig. The pieces are then held together with 1 inch narrow crown staples. For the top bar, 1 staple is put through the side of each end bar into the top bar, then 2 more staples through the top bar into the end of each end bar. For the bottom bar, 1 staple is driven through each of the end bars into the ends of the bottom bar. As the frame is assembled, make sure that the bottom bar is oriented with the drill holes vertical in the frame. After assembly, check to see if the frame lays flat in the jig. If it does not, you can give the frame a gentle twist to make it true. 3/8 inch staples should be added next to the wire holes to support the tensioned wire and keep it from cutting through the wood. The location of the staples will be different depending on if you will be wiring by hand, starting from the top bar, or if you'll be using a wiring jig, as I do, starting from the bottom bar. The frame plans from horizontalhive.com show the former, but I will demonstrate the latter in preparation for wiring using a jig. To prepare for using a wiring jig, staples are added inside of each of the outer holes on the top bar and outside of each of the inner holes. To say it another way, if you look at the holes as a left pair and a right pair, then the staples should go between each pair. The bottom bar just gets 2 staples, each on the inside of the inner holes. I built this wiring jig using plans from horizontalhive.com. I'll also put a link to those plans in the description. It makes the task of wiring a frame much faster and less awkward. Besides the wire, you'll need some wire nails, a tiny drill bit for pilot holes, and a pair of gloves. The frame is put into the jig and clamped in place. Then pilot holes are drilled in the end bars close to the bottom bar. It helps to start the wire nails in the pilot holes, just pushing them partway in like thumbtacks. The wire is fed through the first hole in the bottom bar, passed through the matching hole in the top bar, around the insulator, and back through the next set of holes. You continue around the insulators and through each set of holes until the wire comes out the last bottom bar hole. You may have to help feed the wire from the spool as you go, and if the wire gets a little tangled on the spool, don't force it. A kink in the wire will create a weak spot that's likely to break when you add tension. Once the end of the wire has come through the last hole in the bottom bar, then wrap it around the wire nail 3 or 4 times, hammer the nail in, then twist the wire a few more times to break it off at the nail. Once the end of the wire is attached, then you can begin tensioning the wire. The instructions show to alternate pulling the wires toward and away from you, but I've found that it works well for me to pull each wire toward me as I go, making sure that the wire is still going around the insulators because sometimes it slips off. Pull on the second wire to put tension on the first, then pull the wire off of the first insulator and stretch the second wire again. As you do this with one hand, your other hand should be on the wire spool, taking up slack and preventing wire from being fed as you're adding tension. Once you've worked your way back to the 4th wire, the one closest to the spool, then grasp the end of the wire and, while keeping it taut, wrap it around the wire nail on that side. Just like the other side, wrap the wire 3 or 4 times around the nail, then hammer in the nail and twist the wire a few more times to snap it off. The strings should ring when plucked. And yes, you must pluck every string. Maybe it's not absolutely necessary, but it's very satisfying. One of the most common methods of adding wax foundation to a wired frame is to run an electric current through the wire. This causes the wire to heat up and the wax melts around the wire. I use a 12-volt deep cycle battery and a set of jumper cables. Some use a plug-in transformer, like an old laptop charger. But the important thing is that it has a low voltage. Foundation helps to provide a guide for the bees and prevent cross-combing. You could add full sheets of foundation, but I prefer to use smaller sections to give the bees a start and then let them build natural comb below. Besides that, using partial sheets is more economical. The sheets I'm using are Langstroth foundation cut to the width of the Layens frame, then cut in 1/2 lengthwise. This gives me 4 1/4 inches of foundation to give the bees a start. I lay the frame with the top toward me and the bottom elevated, in this case on a block of wood. As the wax melts, the foundation sometimes moves, and this will help it to slide toward the top bar, if at all. It helps to do this on a warm day so that the foundation will lay down and contact the wires across the frame. Once the foundation is laid down, then the electric leads are touched to the wires at each end. I've found that, using the deep cycle battery with these points of contact, about 5 seconds of contact is enough to melt the wax around the wires without going all the way through. The less distance between the leads, the faster the wire heats up. And the wire can get hot quickly, so be careful not to burn yourself. It takes a little practice to melt the wire right to the middle of the foundation without going completely through. If you watch the foundation as I do this, you can see the wires become more visible as they melt into the sheet. The current should be removed just a little before the wire is completely melted in, because the wire won't cool immediately. If not all of the foundation is in contact with the wire, then it might be necessary to heat the wire, then press the foundation against the wire.
So now, after having gone through the steps, we have one or many Layens frames wired with foundation mounted and ready to go into the hives. Now, if you take on this yourself to make your own Layens frames, I strongly encourage you to repeat each of the steps to make a lot of top bars. Make a lot of bottom bars, make a lot of end bars, and then you're ready to assemble them. And before you know it, you'll have a stack of frames ready to go into your hives. So I hope you found this video useful. And if you did enjoy this video, then here's another video that you might also like. I sure appreciate you watching. I'll see you next time.